So thank you, Julie, for the introduction. So as she mentioned, we are going to talk about the dynamic API delivery with Zilla, where we are, and where I'll be explaining how we can leverage the power of async API in the event-driven architecture. So before we dive in, I would like to introduce myself. My name is Ankit. I'm a noob level open source contributor. I have experience building, designing APIs and real-time streaming platforms for enterprises like Walmart. I am also a little bit of a self-acclaimed expert in Apache Kafka. And along with being an engineer, I'm also a psychologist. So let's dive in. Now, as many of the speakers have explained before, there are a lot of use cases associated with event-driven architecture. So I'm planning to reduce this, as you guys have already have gone through this multiple times. The use cases are all the trivial ones that we see every day in our work or even in our personal life. So it can range from logging to tracking to migrating from a traditional HTTP-based a very legacy-based system to a streaming-based system, or if you want to provide access to your external partners through security and through scale, also to control the IoT devices or to track their information in real time. Now, when I talk about all these use cases, if you were to design these flow individually, I think this type of architecture, it is what comes to our mind, right? Like even in our previous session, thank you, Ruchi, for detailedly explaining how Kafka and MQTT works. If you look at the last flow, in this particular diagram, the IoT device will talk to MQTT broker, which connects to Kafka connector, which ultimately talks to the Kafka broker. Now, it's all good. EDAs are very helpful, but at the same time, these systems are very complex to design, to maintain, to scale, because the one problem is that a lot of individual modules are introduced, which are either procured or which are either made in-house or some hack put in place, because the problem that primarily we face is there are different protocols involved in this one entire flow. Like for example, the IoT device might talk in MQTT protocol, but the Kafka broker or the Kafka cluster doesn't have the capability to understand the MQTT protocol directly by itself. So other problems associated are logging, other problems are monitoring, security. Let's say, how do we secure the client-side interface and also the Kafka cluster-side implementation. So to handle all this, that's the problem that we were trying to solve at Activity. We are able to come up with a solution called Zilla. Now, what is Zilla? So Zilla is primarily a multi-protocol event-native edge or service proxy. It has no state of its own, like you don't require additional broker to maintain its metadata, or there is no data replication happening as such. Also, Zilla doesn't depend on any third-party libraries. Like for Zilla to talk to a Kafka cluster or a Kafka broker, it doesn't need to have the Kafka client library. It understands Kafka wire protocol by itself. It doesn't need to use any connector. It doesn't need to use the consumer and producer APIs. Also, Zilla is extremely efficient in terms that there are no objects allocated to the data flow path at all. So there is no garbage collection and stuff like that happening. Now, we have been talking about all this, EDA standards and use cases and whatnot. So when talking about the standards in EDA, that's where Async API comes into the picture, right? So as mentioned previously, Async API has been widely adopted in EDA community. Every organization who wants to have a standard EDA model or a platform probably try to adhere to async API spec standard. Now, what we thought is that why not leverage this information? Like, let's say someone wants to create a EDA where there is a MQTT protocol involved, like a IoT device which wants to talk to a Kafka cluster. And let's say we already have a spec which defines the MQTT entire flow, all the information, like what is the send information around the clusters, information around the schemas, and leverage that to have the Zilla engine to do all this work for them. So in this example, I have taken a very straightforward, the classic street light example that's available in the AsyncAPI Git repository as well, in case you guys want to go through the complete spec. So the things that I wanted to point is the protocol, the host, the schema information, and so on. So before explaining further, I would like to go ahead with a demo, which is So in this demo, what we are primarily going to do is we are going to take that async API spec file and we are going to convert it into a zilla.yaml file, because zilla.yaml is the spec file that is taken in by Zilla to understand how the entire flow would look like. So we have an inbuilt tool in Zilla that will help you, convert or translate your async API spec into Zilla understandable content. So let me just execute that. Probably not here. So let me expand this slightly. So as you can see, the Zilla dot, sure. Okay, perfect. So as you can see, this is the async API. This font is okay, or should I increase this even? Okay. So this is the async API file that I just converted into zilla.yaml. This uses the 3.0 spec, which is getting released soon. So as I have mentioned, we have all this information around server, around what is the send information, what is the receive information, information around schema, and that gets translated into a zilla.yaml file, which is here. So as you can see, so a Zilla.yaml file is directly used by Zilla to build a complete flow. Now this can be easily, hold on. Now this entire flow can easily be created by using the Helm chart that already exists in our repository. And we also have a setup script in case you guys are interested to give it a try. You can just start this using the setup.sh script. For the sake of time, I have already started this particular service. Now, what I'm going to do here is I'm going to start a Mosquito client. So Mosquito client is what we have used here to mimic a IoT device. So I have started a Mosquito subscription or a consumer. So it's going to look for any upcoming IoT messages. Now in the another window, I'm going to push a message pretending to be an IoT device. So in this, since we are talking about light bulbs, I'm going to send the status of the light bulb where the ID is 1 and the status is turned on, like on. So as you can see, the data is received here. Now let's see your IoT device got corrupted and it is trying to send some garbage data where instead of, let's say, instead of status, it's trying to send stat or something like that. So if we're trying to send that, if you notice, we receive a disconnect 153. So 153 translates to the payload not being valid in MQTT standards. Now, one interesting thing to note here is the Mosquito client is behaving as if it's talking to a MQTT broker, right? That's our understanding in here. But if I do the font size of this one is okay? Yeah, little bit. Okay. So, but if you see here, there is no MQTT broker at all. There is just a Mosquito client and a Zilla instance running. So, what is happening behind the picture is Zilla is acting as a MQTT proxy, where from the client's perspective, the client will talk as if it is talking to a MQTT broker. But Zilla, there is no MQTT broker at all. So the problem that we solved here is, if you remember the previous example where we need a MQTT broker and then we need a connector and then we need a Kafka broker, that entire pipeline can be simplified where just we can place the Zilla. Zilla can directly talk to Kafka because it understands the Kafka wire protocol and it understands the MQTT protocol and it does the translation and just push the IoT data to directly to one of your topic without having to have another set of storage, another set of replicating the data, another hop in the network. So these are the problems that we try to solve here. Now, coming back to what Zilla is actually. So if the question is arising in your mind, like, is it just a MQTT proxy, or is it just a, just an application or just a project that, translate MQTT protocol into Kafka wire protocol? No. So Zilla is a very generic proxy. So Zilla supports multiple different protocol, ranges from HTTP, gRPC, SSC, MQTT, and in future we are also planning to add few more protocols. Not just protocol translation, we have also able to solve problems related to security. Because if you are making a product that you want the people to use in production or in enterprise, I think security is one of the main concern there. So you have to handle the security from Kafka side as well. So we do understand SASL and how it can be configured in the SASL, like all the SASL information can be configured in the zilla.yaml file. Also, we understand the HTTP side of, or the gRPC side of security, where that can be handled by JWT or the token-based authorization. In addition to security, we also have logging, we have monitoring, we have support for Prometheus, where you can extract all those information, put up a nice and beautify Grafana dashboard, or you can set up your alerts. We also have support for validation natively. So let's say you have a inline schema like we have in all of our AsyncAPI documents that can be just directly translated and can be used for validation without you having to specify it manually. Or if you have, let's say, schema registry, which is getting used by your Kafka cluster, you can leverage that. So even before reaching your Kafka topic, or even before reaching any other services or a streaming service that you have in the background, Zilla will help you validate all your MQTT messages that's coming in. Now, in addition to the validation, there is a problem. Like, let's assume that the MQTT, the IoT device that is talking in a MQTT protocol, it wants to translate a message in only JSON format, like you saw in the demo, right? ID, status, and stuff like that. But imagine that there is a strong constraint put by your Kafka team or the Kafka management team that all the Kafka topics should have data only in Avro. Now, situation like this can easily arrive, right? Because Kafka cluster is sometimes, or not sometimes, most of the times is shared by all other team. So in case they want to maintain a consistency and say, hey, it doesn't matter from where you are getting your data, but I want data in the Avro format. So all these are natively done in Zilla itself. Like, it doesn't matter if you want to have like data in Avro or JSON, If you have JSON coming from your source and putting it in Avro, that's possible. The other way around is also possible. So all this translation, conversion is all happening in Zilla in real time. So that's there. Now, how does Zilla works, right? All this sounds very interesting and kind of fantasy in some sense. How we are trying to do this translation. So imagine Zilla as a new way of thinking about stream communication. So in Zilla, every protocol is actually a stream. And since Zilla understands every protocol natively, it makes it easier for us to convert one protocol into another through those streams. Also, how we are able to generate high throughput is by, as I mentioned earlier, by not allocating objects in the data path so that we don't have to go through this garbage collection. We also have back pressure control. So in case the one side of your cluster is not able to take so much of load coming in, then there is obviously that back pressure getting handled. I think, yes. So since Zilla is an open source project, we also have a lot of examples that are curated to specific needs. Like, let's say someone is interested to try it out, HTTP Kafka example. That can be easily done. Or if someone is interested to do a gRPC Kafka example, that can be easily done. So we have Helm chart available for all these examples. It's hardly going to take not more than 5 minutes to have a entire flow up and running, like we just did in the example. At one point, we just have a AsyncAPI spec, and within 5 minutes, we have a complete end-to-end running system where IoT devices was able to translate message and consume message. Now, at Activity, where we are building Zilla, so we have made Zilla as an open source project, and it's a constantly evolving project. It's constantly worked and contributed. We have a ton of features coming in are in the either incubator or in the roadmap. So the next protocol that we are planning to add is going to be webhooks, and then hopefully in future the GraphQL. So that being said, coming to the final slide. So if you guys have any questions.
Why are you laughing? Okay. Does anybody have any questions? Questions? Anybody? Okay.
How does it handle the Kafka partitions? Suppose it has to go to a particular partition. How can I specify it through the proxy?
Generally in Kafka, the partitioning happens based on key, right? Like, so you can have a key added in your payload. That, let's say you're sending an HTTP request, you can have a key defined, or you can have a correlation ID or something like that, which can be used by the Kafka by default. Like Kafka has this ability to understand this particular key should go to this particular partition. So you can actually transfer that message to Kafka, and Kafka will take care of pushing it into the right partition. So you can specify, if your question is, can you specify idempotency key or a correlation key or actually a key in certain format, then yes, that can be done. Even if it is like a HTTP request where you have a header, so you can add all this additional information as part of the header, and the translation will happen at Zilla. Yeah. Looking from a producer side, we are just translating the message to another protocol. In this case, wire protocol, which Kafka understands, and pushing it to Kafka. But the consumer part or the fetch part is slightly different. So let's assume you have a Kafka cluster, you have Zilla, and you have 5,000 clients. Now, it doesn't really make sense for me to hit Kafka topic 5,000 times to get the same message. So Zilla maintains a cache where it fetches the message one time from the Kafka topic, and it doesn't matter how many thousand clients or how many clients it have, it doesn't matter. It's gonna serve from its own cache rather than hitting a Kafka broker as such. So what's the problem that this particular feature helps solve is that you don't overpressure your Kafka cluster as such. You can, like since Zilla is stateless, you can scale this up. It has auto scaling feature as well. So it can automatically scale based on the number of requests coming in. And you don't have to increase the bandwidth of your Kafka or add more number of brokers to accommodate such requests. Yes.
See, be it Kafka, or you can do the same thing for other brokers. All these brokers have their own quality of service in terms of publish acknowledgement,
Yes.
consume acknowledgement.
True.
If you're fronting these things, especially with caching and so on, are you replicating the functionality of the broker?
So not exactly replicating, like in case of MQTT, that the example that you saw, yes, we are, because at one point you cannot tell whether, from a client's perspective, you cannot tell whether you are talking to Zilla or you are talking to MQTT broker, because it talks like the client talks to Zilla using the same format, same protocol and everything. Yes, and that scenario, we have to have some features implemented, like to understand the protocol and everything, but we don't have as such a storage mechanism that, hey, Zilla is going to be another storage or another broker that you add just to store all your data. No, that is not happening here. The cache is just so that more number of clients can consume it. This cache cannot be termed as a storage as such, because if the instance goes down or if a new instance starts in between, the entire cache goes away. But the new instance of Zilla that boots up, it's gonna bootstrap those messages again into its cache.
Makes sense. Pretty interesting. I can see the protocol translation and value. Is there any real world business case that benefits from this?
Definitely, a lot of them actually. There is a very interesting use case that came to us recently, is all this traffic management data that's happening, which is obviously an IoT device, right? Now, let's assume all these IoT devices need to push data to a event streaming platform, right? And now having these many hubs is introducing latency. It's compelling the user to create custom solutions, to add additional modules to support those, design those, and so on. You understand what are the complexity that comes in as we add more pieces to the puzzle. So yes, there are a lot of use cases. Another use case is HTTP Kafka translation, where you want your REST API to use Kafka cluster as a backend. In that case, you can use Zilla, and the HTTP client will feel as if it's talking to a HTTP server. That's it. No change, no understanding of what topic is or what partition is, doesn't matter. So a lot of use cases. gRPC is a very, gRPC to Kafka is a very utilized use cases.
So, say if your Kafka is deployed across different regions in an HA, so would it support such kind of use case?
I think right now, we have an option to configure your Kafka cluster, but high availability and the failover, I don't think we have that feature right now. But you can have multiple instances of Kafka configured with different Kafka cluster details, and that can take care of it. But as such, I don't think we have this failover scenario implemented. And to add to that point, so when I say all these multiple protocols, what we generally think is that, okay, so if I have MQTT to Kafka use case or gRPC to Kafka use case, I have to have so many Zilla instance. But that's not the case. You can have just one Zilla instance, and you can define all these protocols and all these translation in one single YAML file, and that's it. That should, once you deploy it, the one instance can take care of all these translations and protocols. Kafka and any other platform that understands works with Kafka wire protocol, like for example, Red Panda is something that uses a similar Kafka wire protocol thing, so it works with all that. Yes. Mhm. Yeah. So if I can use my screen for a minute.
Um,
Time is up. So
Time is
sure.
up.
Sure.
Sorry.
We'll talk later. Yes.
Sorry for being a party pooper, but don't worry, we will have a 30 minutes break coming up, so
Yep.
make sure to meet up with Ankit.
Yep.
Ankit, thank you so much. If
you.
you do have any follow-up questions, please make sure to use the break. Come and talk to Ankit, and he will be there to answer your questions. Let's give a round of applause for Ankit.